Question 2a, saying a new physical quantity x is defined as x is equal to force multiplied by time squared over mass multiplied by length. Question 1, determine the dimensional formula of x. Question 2, what is the SI unit of x? So in order for us to determine the dimensional formula of x, we are actually going to use the individual dimensions of the quantities that have been provided, thereby simplifying them until we come up with a single dimensional formula of x. And then after that, we can actually predict or rather determine what the SI unit of x are going to be. So we're going to go to our blackboard and write what we've been given. We're saying x is equal to force multiplied by time squared over mass multiplied by length. So the dimensional formula of force, we have dimensional formula of time, but since it's squared here, it's to be t squared. The dimensional formula for mass as capital M, and the dimensional formula for length as capital L. So we know what to say force. This is not a base quantity. This is rather a derived quantity. And this is derived by the multiplication of mass, length, and divided by time squared. Hence, it's kg meter per second squared. So we're going to get those dimensions and plug them into this formula. So I'm going to say x. I'll demarcate this in the middle here, and I'll say x will be equal to the dimensions of force. We've said it's mass multiplied by length multiplied by time to the power minus 2, like this. And this multiplied by the time squared that we've been given here, over mass multiplied by the length, like that. So we're going to multiply this time squared to the time to the power minus 2. And we know to say if we're multiplying two bases or two powers of the same base, what do? We just add those bases or add those powers. So we're having t to the power negative 2 plus 2 in this case, since we have a negative power which is negative 2 and another power which is positive 2. So what are remaining with in the end? We have x is equal to m l t to the power 0 over m multiplied by l, which is giving me what? Which is giving me ml. And these have power 1s, if you want to put them like that. And if we can see, these are common values. We have ml in our numerator, and we also have ml in our denominator. So what are we going to do? We're going to divide these guys. They'll cancel out, and in the end, what are we going to remain with? We're going to remain with m or x is equal to, let's say x is equal to m to the power 1 minus 1, l to the power 1 minus 1, and we already have t to the power 0 there. That means our x will be equal to m to the power 0, l to the power 0, and t to the power 0. And we know to say any number to the power 0 is equal to what? Is equal to 1. That means this is the dimensional formula of this new quantity, which is x. The dimensional formula is m to the power 0, l to the power 0, and t to the power 0. If you want to simplify this further, you're going to remain with only 1. So if you want to finish or you want to go any further, you're only going to remain with x is equal to 1 like that. Hence, we can just leave it there since we want to find the dimensional formula. So this guy is what we're going to call the dimensional formula of x. And if the final dimensional formula is giving us a fraction, or rather a ratio or a constant, that means x is actually dimensionless. So we can confirm using the dimensional formula that we calculated that actually x is just dimensionless. Okay, so we can go to the next question, which is saying what is the SI unit of x? What is the SI unit of x? So how are we going to calculate the SI, or how are we going to determine the SI unit for x? Since we've already found that the dimensions of x are only giving us a constant or a fraction or a ratio, in whichever way we can put it, or in short, x is dimensionless. That means even the SI unit of this guy is only going to be represented as 1. So in this case, what am I going to say? I'm going to say the SI unit. This is question 2. Question A2, the SI unit of x is represented as 1 like that. And we are done with part A of question 2. We can go to part B. Part B is saying a tank has a cross-sectional area of 2.5 square meters. Water flows into it at a rate of 600 liters per second. Convert the flow rate to cubic meters per second. Convert the flow rate into cubic meters per second. That's question 1. Question 2, how much will the water level rise after 10 minutes? Express in meters. How much will the water level rise after 10 minutes? Express in meters. And question 3 is saying what derived SI unit is represented by the flow rate? What derived SI unit is represented by the flow rate? Okay, so let's collect the data first. We have cross-sectional area, and we also have the rate at which water is flowing into this tank. Okay, so cross-sectional area is equal to 2.5 square meters. Then they've also given us the rate at which water is flowing into this tank. Say it's 600 liters per minute. So rate 600 liters per minute, like that. I'll put m, or I'll put the short form of minutes in order for us to just know that it is minutes. So the first thing is convert the flow rate to cubic meters per second. Question A is saying convert the flow rate to cubic meters per second. So this is actually just unit conversion. We already talked about this, and we said if we have such units, so I'll say that is question 1. We've been given, so we should convert 600 liters over 1 minute. This is the same as this. We're going to multiply these guys by their conversion factors. So we are converting this to cubic meters per second. Okay, so we have 600 liters divided by 1 minute. It's the same representation of this guy that we have here. Now, the other thing that we're supposed to know is how many liters make up 1 cubic meter, or how many cubic meters make up 1 liter. Okay, so let me drop down this conversion factor, or I say multiplied by, I'll start with the minute, the conversion of the minute. So we're going to have 1 minute here which is equal to what? Which is equal to 60 seconds. 60 seconds like that, so that we have the minute there and the minute cancelling each other. Then I'm multiplying by the conversion factor of the liter and the cubic meter, or the relationship of the liter and the cubic meter here, which is 1 cubic meter. So I'll put 1 cubic meter here, giving us 1000 liters. My goal is for this liter and that liter to cancel out, so that I have cubic meters there. Okay, so now we can multiply what we have here in order for us to actually find the final conversion. So I'll say 600 multiplied by 1 cubic meter. I have 600 cubic meters divided by 60 seconds multiplied by 1000. So I have 60,000 seconds. Okay, and this should give me final answer, which is 6 divided by 600, and this is actually giving me 0.01 cubic meters per second. So that is the final answer for the conversion of the rate from cubic meter into, from liters per minute into cubic meters per second. So that is our conversion. Then we have question 2, which is saying how much water, or how much would the water rise after 10 minutes, expressed in meters. So this one is question 2, and we've already been given the cross-sectional area. Say it's 2.5 meter squared. And we also know the flow rate. The rate we are from calculating, and we said this is 0.01 cubic meters per second, like this. So we also know the time. They've given us the time. Say it's taking 10 minutes. If you want, you can convert this into seconds, and you're actually going to get 600 seconds, like that. So I have time in 600 seconds. So after doing this, now what are we going to do? We're supposed to calculate the total volume of water that is going to flow into the tank during this time of 600 seconds. And how do we calculate this volume? We're going to say volume is going to be equal to the flow rate multiplied by the time taken. And this will be equal to the flow rate, which is 0.01 cubic meters per second multiplied by 600 seconds, like this. Hence, we're going to get the total volume that is flowing into the tank as 6 cubic meters, like this. So this is the total volume of water that is going to flow into the tank in the 600 seconds that we've been given, or rather the 10 minutes that we've been given. Now that we've calculated this volume now, we can or we have to understand that this volume of water that is in the tank can also be expressed as a product of cross-sectional area and the rise in the water, or rather the height of that water. So that's the relationship that we're going to use in order for us to calculate the height at which this water is going to rise. So I'll say the h, which is the height in this case, will be equal to volume divided by what? Divided by the cross-sectional area of this tank. So what amount of volume has gone into the tank? We say this is 6 cubic meters, like that. Then divided by the cross-sectional area of this tank, which is 2.5 cubic meters. So I mean square meters rather. So the meter there cancels out the 3. We only remain with 1 meter there. Then we have 6 divided by 2.5. Hence we're going to get the h, height at which this water is rising, as 2.4 meters. So 2.4 meters is the height at which this water in the tank is going to rise. Okay, and the last question, which is question 3, or part 3 rather, is saying what is the derived unit represented by the flow rate? What is the derived unit represented by flow rate? So the flow rate has units, cubic meters per second there, of which in this case, or in other cases, we can just express them as m to the power 3, then we have secondly the power 1 there. So if you want to take, or we've been talking about dimension analysis, you know the units, you should be able to understand what these units that you have there are representing. Found them to say it's m to the power 3 over s, or m to the power 3 multiplied by s to the power minus 1 as a derived unit. And this one just actually represents what we call volumetric flow rate. Volumetric flow rate is the one that has units cubic meters per second. Cubic meters per second. Volumetric flow rate. So flow rate, or if you want, you can put volumetric flow rate is the one that has this kind of units. And if we reach that point, that means we are done with question 2, as it was only having part A and part B, and we've done all the parts. That was the last part, which is part 3 of question B. So register with us for the full solutions to this assignment. You can find them on our website. I've included the link in the description, which is actually discretelearning.com. You can register, make payments, and you'll find all the materials that you're looking for just there on the website. So until then, you can just like, share, subscribe to the channel, and stay blessed until next time.